biolog ecoplate. What it allows us to do is community level functional profiling. And essentially we have a cryopreserved sample that we've put into the solution, and then we've inoculated each well with this biolog plate. And we've incubated it for a few days, and what you see is a purple color change in each well. And what each well represents is a different substrate that's being utilized. So I'm now reading it in our plate reader, and what this is going to do is give us a nice CSV file with all of our different absorbance values for each well. So it's doing a kinetic step at the moment, which basically shakes the well so it's homogeneous before it's scanning through every single well. So the machine's done recording now, and as you can see we have our absorbance readings for each well. So what we're seeing here is this A1 well is for water, and you'll see that there's no, this is kind of the blank in the experiment. And then these are all different substrates. Maybe I can get the substrate mapping showing you. But yeah. So I'm going to pipette our soil slurry into every well of this plate. What this allows us to see is the enzyme activity in our soil that has been cryopreserved. Now our plates are inoculated, we need to incubate them at 20 degrees. So these are our soil samples here, and what we're going to do is we're going to gently cool them down, because at this temperature they're not ready to go into liquid nitrogen. So what we have here is a Stirling cycle cooler, and how it works is there's an engine that drives a compressor, and what it does is it gives us very accurate cooling rates, which is what we need for this application. So this machine also is a high throughput machine. So we have two cooling cells that can accommodate one of these plates. And what we do is we put our samples into one of these, and then the engine will conduct heat and transfer it away from this, cooling it at 1 degree per minute. So this machine is normally used in hospitals when people freeze their gametes. But we're using it for research. You can see that the plate is reaching that temperature. But this is only the first 2 minutes. It gets more exciting later. I don't know if you can hear it in this loud room, but there's the engine starting to spin and reducing that compressor. So now we're going to fill one of our liquid nitrogen tanks, and this is where we store our samples after we cryopreserve them. The reason why we store them in liquid nitrogen is the temperature is effectively minus 195 degrees Celsius, and most biological activity stops at that point. So effectively we're hitting pause in the metabolism of our samples. So our samples are stored in these racks here. So they'll be put in a box, and then they'll be submerged underneath the liquid nitrogen level. What we can see is the liquid nitrogen level is a bit low, so I'm going to fill it up. So we use this mobile tank to dispense liquid nitrogen. How it works is we release the pressure here. And once the pressure gauge decreases to around 15, we can then turn on the hose. So normally our liquid nitrogen tanks, or our samples are stored in these bigger tanks over here. And they're not submerged like in this tank. In this bigger tank, liquid nitrogen is in the sleeve of the tank. So it's never making contact directly with the samples. I'm now going to turn on the hose, so liquid nitrogen is going to start coming out of this. Liquid nitrogen there. So that's almost minus 200 degrees. And safety is very important when we're doing this. So we always wear an oxygen monitor, and we always have a buddy outside in case anything happens to me. So now I've exported the plate data from our biolog plates. I'm now going to upload them onto my workstation. So this is the biolog pipeline I've been working on. And what it does is it looks at the certain files where all my biolog exports are. It looks at that folder, and then it will generate it will map all of the absorbance readings with the specific substrates that are in each well. So if I just play these chunks, I don't know if you can see there, so these are all the different categories for the substrates. So the biolog plates, they contain amino acids, carboxylic acids, carbohydrates, which are really important for ecosystem function, polymers, and then phenolic compounds. So this is just initializing some of the functions, and then it points it to the data. This is just in QC. So in total, it's kind of hard to see, but we have 141 plates of data that this is processed. And if you want to visualize it, this is what it looks like. If I increase this, this works. So what we see here is all the different samples of our cryopreserved samples, and then they are now linked between the storage temperature, which can be 4 degrees, which is the fridge, minus 80, or liquid nitrogen. And then what you see here is the activity for each substrate. So these are all linked by the different category they are. So if you want to look at how cellulose has been broken down, you look at this row here, and then you can see, depending on the storage treatment and cryopreservation technique we use, you can see that there's a varying level of activity. What we really want to see is the same activity as here. So this is our activity before any cryopreservation. So you can see that our treatments actually decrease the activity. But that's horrible to look at, so we can simplify it a bit further. Yeah. So here's an example of me simplifying it to per replicate. So you can see that the data looks a little bit tidier and easier to digest. But you still see that sharp decrease between our time zero and then the data afterwards. Yeah. And then this is what I presented yesterday. So my next steps, I guess, I'm going to interrogate this statistically. So I'm going to have a look at what statistical tests we can use to see if we can get any significant differences between each of these tiles.